Please correct me if I'm wrong, but this is where we stopped, right?
Yeah.
Like this is the first blank spot in your notes?
Mm-hmm.
Okay. So do you recognize this from last year? Did you do some of these last year?
Yeah.
So I hope this is some good news for you. We will not do a ton with things like number one. We will not. We'll do some different stuff with it, but it's not going to really involve a whole lot of what we're about to do. This will be a very kind of a minor point to this as far as how we're going to actually handle this, practically speaking. But we're going to do this here once just to remind you of what the derivative is, the definition of the derivative. And like I said, then we'll kind of talk about what this might look like on a quiz or a test, or maybe the AP test, perhaps, something like that. So let's take a look here. Number one, it says use the definition of the derivative to find g prime if g of x equals x squared plus 2. Of course, maybe you remember this from pre-calc. These can get really ugly, can't they? They're really, really ugly and take entire sheets of paper plus, and the kind of thing where you do a lot of work and you miss one little minus sign and everything is thrown off. It's like, wow, it's really frustrating. Let's try this one really quick. It does say use the definition of the derivative. And so I think maybe a good place to start would be to write down that definition of the derivative. So we would say g prime of x would equal, what's the very first thing that I have to write in order for this to be a derivative? Lim. Yeah, it's got to have a limit on there. So limit, and if you use the easier notation, we'd put limit as h goes towards 0. And then the numerator, here'd be a case where you could really fumble with names of functions. Maybe you already did this. Did anybody start writing this? Do you see why that's a fumble? We're not talking about f prime, we're talking about g prime, right? So be really careful with that sort of thing. This equals g of x plus h minus g of x all over h. Okay, so what we're going to now do is we're going to try to find the derivative of g, just using that definition of the derivative. Oh, is that okay? All right. So our function here, g of x is equal to x squared plus 2. And so when you see notation like this, that means plug in x plus h in for x. It's always kind of that awkward feeling substitution, but that's the direction we go. So we're going to write equals limit as h goes to 0, and then it's going to be x plus h quantity squared plus 2. So that's equivalent to what I have circled in purple, sort of. Let me do a better job. Let me get that g in there. So that's g of x plus h. And what's g of x? X squared plus 2. Yeah, so that's already defined for us. So put minus parentheses x squared plus 2 all over h. Let's not lose sight of what we're doing here. We're doing a limit. And in many cases, isn't the easiest way to evaluate a limit just to plug in the number? If you do that, what happens? Because it's a derivative, it's automatically going to have that issue with a 0 in the denominator. So what do we got to do? There's a lot of ways this can go. This is
eliminate the h in the denominator.
We've got to eliminate the h in the denominator, but Ben, to get there, what might we do?
Expand the square term and cancel out.
Yeah. Start foiling and multiplying and adding and subtracting like terms, things like that. So if you do that, you get limit as h goes to 0. The binomial becomes x squared plus 2xh plus h squared. That's when you FOIL out the x plus h squared. And we still have the plus 2. And then I'm going to distribute that negative, so minus x squared minus 2 all over h. And of course, you see all the lovely things that happen when you do that, right?
Yes.
Several things add out. The 2's add out. And the x squareds add out. Feels like we've done a lot of good work. Oops. Anybody notice my little mistake there?
Yeah.
It's okay to point it out. I don't get offended. So, like I said, it feels like we did a lot of good work here. But don't we have the exact same issue that we had all along? You try to evaluate that limit. Don't you still get something over 0?
Yes.
So what's my next step in order to do what Zach suggested? Factor the h, there we go, you got it. So factor the h out, cancel. So we come up here and we go limit as h goes to 0 of h, parentheses 2x plus h, all over h Now the h that was giving us such a problem cancels. We evaluate the limit. And what do we get?
2x.
So just 2x, because the h goes to 0. So 2x plus 0, technically. So those of you that remember the power rule, you remember learning that last year? Doesn't this agree with what the power rule would have told you? So we'll get to the power rule pretty soon. And we will use that pretty much the whole time. I'm not going to do a lot of this definition of the derivative stuff, at least not in this form. Okay, where do we stand? How do you feel? Good? Questions? Okay, so let's check this out. This next one, this next section is always interesting. Never know exactly how it's going to go. Look ahead in your notes there. It says a graph of f is given below. Sketch the graph of f prime on the same graph. So this is going to be one of those moments where if you have a question, you need to voice it, okay? Or raise your hand or something. Because I'm going to go through this and we're going to, let me actually get this, there we go. Get that on the screen there. We're going to go through this. We're going to go through this slowly. And I want to say that this sort of question, I don't know that it would ever show up on an AP test. It'll definitely show up on some of my quizzes and tests. It won't show up in the end because it's just, well, I can't say that. It used to show up on the AP test at times. It hasn't in a long, long time. It's just very hard to grade, at that level. And so, they don't, it's been a long time since they've had this, but I think it's extremely valuable to understand the interaction between f and f prime, or g and g prime, okay? So let's look here, some key points to consider as we focus on these. We're going to do the one on the left first. So the key points are, we want to ask ourselves, where is the tangent line horizontal? And by the way, what kind of slope do horizontal lines have? 0. So that's really important. So where is the tangent line horizontal? And then the other two, where is the slope of the tangent line positive? Where is the slope of the tangent line negative? If we can discern those three things, we're going to be able to sketch these graphs. And I do want to say a word about sketching the graphs. There is definitely a certain level of accuracy we can have here, but please know that there are going to be certain aspects, and I'll bring those out. I'm not going to grade you on the perfection of your graph. It's going to really be those three key items. Where is the tangent line horizontal, and slope being positive or slope being negative, okay? So what we're going to do here, I want to be super duper clear about this. We are going to take a graph, and I'm going to focus on the one on the left here. This graph is a graph of f of x. So I wrote that in black. And what I'm going to do is right on top of that graph, I'm going to graph f prime. Okay, so let's think this through. I'll do this in a different color. Let's see if you guys can kind of guide yourselves to the answer. Only look at the graph on the left. Do you guys see any places on that graph where a tangent line to that graph would be horizontal? So remember, a tangent line touches the graph in one point. So do you see any places where the tangent line would do this? I don't either. I don't see any horizontal tangent lines anywhere. So that means that f prime is never 0. That make sense? Let's review. What is the derivative relative to the tangent line? It's the slope, right? So the derivative is the slope of the tangent line. So I don't see any tangent lines up there that have a slope of 0. So that means f prime will never equal 0. Later on, we'll look at other graphs where it will, but not this one. Okay, so then where is the slope of the tangent line positive? Again, just focusing on the left graph only. Where's the slope of the tangent line positive? Everywhere, right? Think about that. As best I can represent it. That's just a line, isn't it? Mm-hmm. And what's the slope of that line?
2.
Positive something, right? Positive 2-ish? Maybe slightly steeper than 2, but positive 2 is a pretty good estimate, isn't it? Do you ever see the slope of that line going negative? No. Okay, so another important aspect of this is that's a line, right? So a line has what kind of slope? Constant. Whoever said that? A line has constant slope. So no matter where you look at it, if you look at this point if you look at that point right there, that point right there, any of those points along that line, don't they all have a positive slope? Every single one of them. So here's what I would do. I'm going to graph f prime in green, and here's roughly what it would look like. Stop and digest that for a second. This one is kind of a hard one to start off with because it's actually really simple, and sometimes the simplest things are the hardest ones to see. But I want you to think about this. If I go along this line right here, like for instance, this point right here, when x is negative 2, so when x is negative 2, what is the slope of the black line? 2, isn't it? Didn't you say it was a line with a slope of 2? Mm-hmm. So when x is negative 2, the slope is 2. That is represented by that point right there. What's the coordinate of that point? So that's saying when x is negative 2, the slope of f is 2. Let's keep going. How about this point right here? When x is negative 1, what is the slope of the black line? 2. And so isn't that represented by that point right there? Are you seeing this? Okay. We do another one. So I'll come up here. That point right there is roughly x equals 1. And what's the slope of the black line when x equals 1? 2. And so that would go pretty well with this point right here. So if your f prime graph is a horizontal line, that means that your f graph was some angled line, right? It had a constant slope. And so a constant slope would just show up as, well, whatever x is, the slope will always be the same thing. So that's where you get that horizontal pattern. Whatever your input is, the slope of the original graph is, in this case, going to be 2. So at this point, I'm looking around and I'm seeing a few folks, or if I had to bet money, I would say, yeah, they maybe get it, but I see a lot of folks that are kind of like, maybe not yet. Can we do another one? So the next couple are a little more complicated, but that actually might be a really good thing, as strange as that sounds. So check this out. Look at the middle one. And this middle one, just like before, this is going to be a graph of f. And then in a different color, I'm going to attempt to graph f prime. So here we go. I'll do it like this. First question you can see up there, where is the tangent line horizontal? In this case, there are some horizontal tangent lines. How many do you see? Shout it out.
2.
2? Yeah. So I see a horizontal tangent line right here and another one right there. So I'm going to erase those here in a second. Do you see how the tangent line right there at those turnaround points would be flat, horizontal? That make sense? Okay, let me remind you, what is the slope of a horizontal line?
0.
So, since we're graphing f prime, wherever we see a horizontal tangent line, that's where f prime is 0. So let me erase those really quick. Here's going to be the actual graph of f prime. When x is, I'm going to assume integer values here. When x is negative 3, f prime is 0. When x is roughly 2, f prime is 0. So I've graphed those just directly on the x-axis because that's where there is a value of 0. Does that make sense? It's a real honest question. We can chain the logic together again if you want. We can think of it a little differently. Does anybody have a question? Okay, let me keep going. So then, once you have found the zeros, then the remainder of this is simply where is f prime positive and where is f prime negative. Now let's remember that f prime is representative of the slope of f, right? So I am going to look at this one little chunk at a time. So to the left of negative 3, the part that I've just highlighted in yellow, would you guys say that f prime is positive there or negative there? Because the slope of that curve appears to be negative, right? It's going downhill. Does that make sense? Okay, so if on that interval from roughly negative 4 to negative 3, if on that interval f prime is negative, shouldn't f prime show up below the x-axis? Because isn't that where negative y values show up? Does that make sense? Okay, so I'm going to do this. How about that? Now, why on earth would I draw, obviously that's where the values are negative, below the x-axis. Why would I draw it up to negative 3? Why wouldn't I draw it like that? Yes, sir?
Because it's curving towards a horizontal and not further down.
Yeah, we already know that f prime is 0 at negative 3, right? So, yeah, you could say it like that. You know what? Let's expand on that thought a little bit. think about this. I'll put in some points here. What would you say the slope is right there where I drew that little purple dot? Negative, pretty significant negative slope, right? Let's say -3. We'll go with Riley's idea there. How about right here? What would you estimate the slope there to be? -2-ish. Certainly a bigger number than -3, right? How about like right in there? -1. And then, of course, we get to right about that point right there. And that's where f prime is 0. So f prime went from -3 to -2 to -1 to 0. Don't you see that pattern taking shape right there? Roughly, I mean, if we want to extend this down just a little bit to get to that -3, -3, -2, -1, 0. My goal here is that you see how these are going together, that this seems logical that you could reproduce this. Starting to see a few more confident faces. Okay, let's keep going. Oops. There we go. Okay, so then the next interval would be from -3 all the way over here to 2. What would you guys say the f prime value would be on that interval? Because doesn't it seem like that's going uphill? Now, of course, in varying degrees, but it's going uphill the whole time, right? And so positive numbers are all above the x-axis. And so what I would do here, get rid of that yellow, is I would draw something like that. I'm going to curve it back downward because I know that when x is 2, f prime is 0. So I certainly can't do this, right? Because I already have that 0 established. It's got to curve back down and hit the x-axis when x is 2. Okay, and then our last interval would be from 2 to 5. On that interval, what would you estimate f prime to be? Negative. Agreed. And so negative numbers are numbers that are below the x-axis. So I would just do something like that, roughly, and call it good. And I'm going to label that f prime. Can we talk about how I would grade one of those if that were on a quiz? What would you think? Like, what if I had a paper and the person on their paper drew this? What do you think I'd do with that? Full credit, partial credit, no credit? Okay.
Partial credit because it makes it look like the high slope you get is 3, and it doesn't look like on the graph it gets anywhere close to that.
Okay, fair enough. Anybody disagree with him? Think it would be no credit or full credit? He said partial. What do you think, Ben?
I'd say full credit because even though, like, yes, you can kind of see how it's not really 3, like, it's still just kind of like a best guess because you can, like, you're not, it's not going to be like a perfect kind of half circle.
Okay.
Like, nothing's really perfect.
Okay. Anybody think it would be no credit? You're all so optimistic and sweet. So innocent. So the honest truth is, I'll let you know right now, I'm pretty sure that if somebody submitted that red graph, I'd give them full credit, right? And let me explain why. Like, your observation is correct. Like, maybe I've gone a little too high or a little too low in some places. Your observation is definitely correct. But here are the 3 elements that I would be looking for are the 3 elements you see up there. Do you have the correct zeros? Like, have you correctly identified where the tangent lines are horizontal? Do you have the correct zeros? And then, is f prime positive in the right places? And is f prime negative in the right places? There would be some interesting things that could happen here. This one I'm not so sure about. You know, because all those little ups and downs in between kind of have a significant meaning. And so I'd probably go partial on that, even though you've got all the elements, because I'd just be like, why? Why'd you do that? And they actually do have some significance, you'll find later on. So I don't know what I'd maybe like 2.5 out of 3 or something, because you pretty much got it all there, but you kind of went off the beaten path with that ups and downs stuff. Yeah.
Why is it more of a straight line on the right side?
Why is it a straight line on the one on the left?
No, yeah, and then the middle one. Why is it on the right, like the purple graph? Why is it more of a straight line going down?
Oh, on the right? Just because I kind of ran out of room on the graph. It probably should curve.
Okay.
Like
It's just less of a slope than the one on the left side.
yeah, maybe it should do, oops, maybe it should do something like that. be a little curvier. I just was trying to keep it on the graph. I felt like I was going to go off the graph. But that'd be a good example of something I would not differentiate between. I wouldn't be like, well, Catherine, I'm sorry, your line's a little straighter than I wanted, so -1 or something like that. I'm not going to do that. I'm going to be like, yeah, you've got all the elements there. It all is reasonable and makes sense. Yeah. Hey, I think it's really important for you guys to understand how you'll be assessed. Have I done a good job explaining that? Hey, please listen. Have I done a good job explaining how you would be assessed on that? If you're feeling confused, you need to let me know, because I don't want there to be any mystery and be like, what? I didn't expect that. So let me show you one other thing here that might happen that I think would be cause for concern. Let's say you've got your zeros in the right places, but let's say your graph looks something like this. Like you just have this urge to curve the tails back up towards the x-axis. Similar to the one where I had the squiggly ups and downs, this has a similar important meaning where you're heading back towards 0, or especially if you ended up like back at the x-axis, like that and that. Those, of course, would have significant meaning, right? Because that's where f prime would be 0. And so I'd be really careful about just like feeling like you need to curve things back towards the x-axis. You got to understand, I say these things not randomly. These things happen, right? And so, again, that has significance. And so you want to just like be really disciplined about, am I really heading back towards 0 with f prime? Yes or no? You want to answer that question correctly. Because again, this one like mostly has all the right elements there. I mean, they're all in place. But curving back towards the x-axis means something. You got to be really careful with that. Have a good reason for doing what you're doing, and you should be okay. Okay. So I feel like at this point, we are pretty close to being on board with everything, but maybe not all the way. So I thought maybe we could do this last one here. But let's do this last one on the far right with you guys trying it first. If you haven't already done so, please try the far one. You could look at each other's papers, discuss. This is like a group project here for this one. But we'll discuss the answer in a few minutes, see how it all turned out for you. Okay, ladies and gentlemen, let's try to clear this up as best we can. So remember the 3 things I'm wanting to see from you. I'm wanting to see, do you know where f prime is 0, also known as horizontal tangent lines? Also wanted to know, do you see where f prime is positive, where f prime is negative? That has to do with, where is the slope of the graph, positive or negative? So how many zeros did you see? 3, yeah, 3 zeros. I'd say one of them is like right over here between -3 and -4. The other one is pretty close to -2. The last one is just a little bit more than 2, roughly. Somewhere in there, those 3 zeros. And then once you have those 3 zeros established, and I really think the order is important. I think you want to find your zeros first and then start doing the whole where is f prime positive, where is f prime negative routine. So we look at this over here. Would you guys say that f prime is positive or negative on that interval? Positive, and so that means that f prime needs to show up where? Above the x-axis, but of course, heading to about that point right there. Okay, the next interval goes from there to there. Would you guys say that f prime should be positive or negative on that interval? Negative, and so f prime needs to show up where? Below. If you can get that pattern down, then these should be pretty straightforward for you. Below, however, it's heading back towards 0 when x is -2. And then, of course, this interval right here, f prime looks like it would be positive because f is increasing, right? And so we need to be above the x-axis, but heading back down towards roughly that point there. And then for the whole last stretch to the right there, f prime appears to be. So it needs to show up where? Below. Okay, so maybe something like that. Roughly, and we're in good shape. Hey, could we revisit really quick the very first one we did? Does that one make a little more sense now? Do you see how there's no turnaround points, no smooth, curvy turnaround points? And so there's no zeros. And you see how the slope is always positive, so shouldn't f prime be always above the x-axis? Yeah, Lainey.
So with a line like that, the f prime is always going to be horizontal?
Yep. So, and the reasoning behind that would be, is if you have a line, the slope is always the same. It's always constant. So when you graph f prime, all the y values should be the same, leading you to a horizontal pattern. Great question. Anybody else with a question? Go ahead, Josiah.
If there, so say that the line was, I don't know, like say that it passed through y is equal to 5 just that point, and x is equal to 0 at that intercept, would that be at where it crosses the y-axis, would that be where the...
Let me clear things up. When you say the line, are you talking about f of x
Sorry,
or
yes,
f prime?
If you're trying to find the derivative of f of x, so say that f of x is a different line than...
Okay, let me write this up here. So f of x, different line, what does it look like?
Let's just say it just passes through the y-intercept at 5.
Okay.
And so would that be...
What else about that line? Is it positive slope, negative?
Positive slope of 1.
Okay.
So would the derivative be a horizontal line at the point 5?
Okay. Hey guys, this is a good question for the group. So what Josiah has given me here, he said this is a graph of f of x. It goes through the y-axis at 5, so the y-intercept is 5. He said that it has a slope of 1, right? So y-intercept 5, slope 1. And his question was, let me make sure I said this right, he said, would the graph of f prime be a horizontal line through 5? Right? What do you guys think of that? I'm seeing a couple of these and a couple of those.
No, it'd be x equal, right? The slope?
Y equals.
Y equals.
So Josiah, Catherine, I think a few others had this as well. It would actually be a horizontal line through 1 because the reasoning would be that you said the slope was 1, which is fine. Remember that f prime is graphing the slopes versus the x-axis. And so you told me that no matter what the x, essentially what you're telling me is no matter what the x value is, the slope is 1. And so the graph of your derivative would need to reflect that. So whatever the x coordinate is, it really doesn't matter. The y value would always be 1.
So, yeah, I guess my question was like, if you didn't have numbers on the graph and it was just the general idea,
Yeah.
how would you see it?
Just do your best, right? So I'm not going to get out the ruler and be like, I'm sorry, it was actually 1.2 and you had it at 1. Not going to do that. That's unreasonable. So do your best to place it about where it should be, but don't be getting out the ruler and measuring in millimeters and all that stuff. Yeah, go ahead.
So you could judge a relatively okay sketched graph of x through f prime of x, like the middle or far right graph, if you wanted to. For like the first graph of x, I don't really feel like you could because you don't know what y-intercept would be at all.
We don't really care about the y-intercept. We only care about the slope.
What I'm saying is you want to go from f prime to f.
Oh, what? Now, so that's a whole different thing. That's a whole different process. That's antiderivatives instead of derivatives.
Yeah.
You've actually hit upon a very important point, which we'll talk about in November.
Oh.
No, that's a very fair point. Just not where we're going yet. Okay, ladies and gentlemen, I hope that worked for you. We will try to practice that as much as we can in the near future. But for now, there we go. For now, we are going to focus on this right here. I hope the video worked well for you, like I said. Please, again, do not assume because we haven't had quizzes over the videos that that'll never happen. I can assure you it will. It's just a question of where it fits in and how it fits with timing and everything. And just haven't felt like it was there yet. So anyway, take that for whatever it's worth. Let's jump ahead. Let's look at what we have left here in 2.1. Similar to what we've been talking about. This is not a radical right-hand turn or anything like that. We've been talking about this for the last few minutes. I really appreciate your good questions. Please don't hesitate. Sometimes it's your questions that move the class forward in the direction it needs to go. So don't hesitate to ask. All right, so what we've got here in this example, if you've jumped ahead in your notes a little bit, we've got a graph of f. It's right there. Maybe notice a few interesting things about it. But it says in number 1, the question says find the x value where f is not differentiable. Use the definition of the derivative with one-sided limits to justify your answer. That is pretty darn specific, isn't it? It didn't say make up your own method for showing this. it said use one-sided limits to show this. And so we want to do that. Where is f not differentiable? Where does it appear to be, just like by glancing at the graph? Do you see it? X equals 0, right? It looks like this is a piecewise graph. Looks like the left side appears to be a line. And what does the right side look like to you? Parabola-ish, maybe? I mean, it's really hard to know for sure. It could even be a sine or a cosine graph. It's hard to tell. But it's clearly not like the piece on the left. Okay, so where is f not differentiable? You all said it. Well, x equals 0. I'll put it like this. F is not differentiable at x equals 0. So if this were a quiz question, you probably got the first point, right? You've identified the point of non-differentiability. But then it says, use the definition of the derivative with one-sided limits to justify your answer. If I remember correctly, this was in the video. Let's check this out. I'm going to say limit. I'm just going to follow the directions. Limit as x approaches 0 from the left of this. F of x minus f of 0 over x minus 0. So that's the difference quotient, the definition of the derivative from the left of 0. So I want to actually try to put a number to this. What is your best estimate for this? As we approach 0 from the left, what would you say f prime would be?
2/3.
Let's see here. Yeah, 2/3. I like it. Can't you see, if it is a line, can't you see that the rise is 2 and the run is 3? See it? I think we can actually put a reasonable estimate of 2/3 on there. Can we say for sure positive? But I think because it's a line, we could get pretty specific and say that it's 2/3 the whole time over there. So I'm going to put that. I'm going to put equals 2/3. That's from the left. Yes, sir.
So can we just like say we looked at the graph and we said it was 2/3, like
Yeah.
draw the little lines? Or
I don't think you have to draw the lines. At this point, finding like the slope of a line, I'm comfortable you just saying rise 2, run 3, 2/3. I'm okay with that. Okay, so then that is not equal to, we can see it from the picture, that is not equal to the limit as x approaches 0 from the right of the exact same expression, same difference quotient. What could you say about the value of f prime as we approach 0 from the right? We can't really say 2/3, but can't we say what Jake just said? Isn't it pretty clearly negative? You know, on this whole interval, right to about there, it's pretty clear that f prime is negative on that whole stretch. And so a negative number could never be equal to 2/3, could it? Therefore, we've shown that the behavior of the derivative from the left and the behavior from the derivative from the right are different. Therefore, it's not differentiable. Is that function continuous? Does f appear to be continuous at least?
Yes.
It does. Remember from the video, perhaps, I think it was in there, that it's possible to have a function that is continuous, yet not differentiable. Is that sharp point idea? And so we've done the first part. Do you guys have any questions on that first part? Pretty notation heavy, right? Yeah, go ahead, Rod.
So is 3 differentiable?
Is which differentiable?
Where x equals 3, like why is that not, or like why is it considered not differentiable?
You know, it's really hard to tell from a graph, but I would say that, and you're talking about right here,
Yeah.
right? So I would say that that appears to be a pretty smooth transition, right? So the idea would be if we started looking at points in there. So let's say I put a point right here. Let's just make up some numbers like we did before. What would you say f prime is right there? I tried to highlight it in yellow. Can you see it? That's where the line seems to disappear.
Yeah. Is it like the slope?
Yeah, what do you think f prime would be there?
Like -1/2?
Okay, how about right there?
Like -1/4?
Sure. How about right there?
Like almost 0?
No, how about -1/16?
Okay.
How about right there? -1/64, right? And then, you know, right in there, how about -1/1000? And then we get closer and closer to x equals 3, and we finally say, okay, f prime would be 0. And then as we leave over here, it'd be like, okay, the slope is 1/1000th, 1/20th, 1/10th, 1/2, 0.9, 1, whatever.
Yeah.
You can see that that transition from a negative slope to a positive slope was very, very gradual, right? It happened like, little bit by little bit by little bit, where it's very different over here. There is a transition. So like, if I were to do kind of the same exercise on the line now, I'll use a different color. How about this color? If I were to say, what's the slope? What would you say? 2/3, right? What's the slope? What's the slope? What's the slope? What's the slope? Negative something, right? Yeah, -1, negative something like that. So you went from a slope of 2/3 to a negative slope, and it happened just like that. That's what characterizes a non-differentiable point. So these are all these things that I've just been doing, I think are pretty good descriptions of differentiability versus non-differentiability. Please don't use that kind of reasoning to justify yourself. Don't say the slope went from 1 to 1/2 to 1/4 to 1/8 to 1/16 to 1/32. Like, nah, use the limit thing. The limit is what allows us to say closer and closer and closer and closer. But that's kind of sort of a description. Is that okay?
Yeah.
Okay. Go ahead, Zach.
So if piecewise function with like two parabolas on both sides, they both kind of like come together. It's still
Sure.
non-differential, right?
Yeah, so like that sort of thing?
Yeah.
So like right there, yeah. So you went from clearly a positive slope to clearly a negative slope, and it happened just like that, not differentiable.
Okay.
All right, any other questions? That was a really good what if question. Colin?
But I think it's still, like, the limit is still positive or negative and then positive, so.
0 at 3.
But it happens gradually.
So it has to be, like, instantaneous?
So the question I would come back to you, so the change would have to be an instantaneous change to generate non-differentiability. So like what I would say here, like that little exercise we did with Riley about, on the right side over here when I said, what's the slope, what's the slope, what's the slope, what's the slope? I would ask you, how close could you get to 3 to see that transition from negative to positive? You could get infinitely close. So the closer and closer you get to 3, the slope is going to go like negative 1/1000th, negative 1/1,000,000th, negative 1/1,000,000,000,000th. And eventually you transition from a negative to a positive, and because of the IVT, right, you'd have to hit 0 in between. But if it happens gradually and smoothly versus boom, boom, it's differentiable versus not differentiable. And again, boom, boom is not a justification. So if you had, let's say, some piecewise graph, and I'll try to do this, I'll do it like this. So you've got y-axis, x-axis, and let's say piecewise again, let's say one piece does this, and let's say the other piece does, I'll shift colors here, let's say the other piece is like that. That's not differentiable. Because you've gone from a linear graph of slope 1/2 to a linear graph of slope maybe 1/4.
Okay.
And that transition from the slope of 1/2 to a slope of 1/4 happened instantly, just at a point, making it not differentiable.
Okay, so if it's like a really sharp parabolic something though, is that still
Sharp
It's
okay. So instead of like instead of like a fat parabola like this, it's like a one of those. Yeah, maybe we should call that one of those. Yeah, I should probably stop saying that word. That's still differentiable. Still differentiable because you can show that the limit from the left of the derivative, limit from the right, are the same. So even, so like this one might have been y equals, like 1/4 x squared. And even if this one here is y equals 1,000,000 x squared, I mean, that would be a really tall, skinny parabola, right? And that vertex would be a very quick transition. It would still be slow enough to be differentiable. So the way that you typically would create points of non-differentiability would either be through piecewise, like we've looked at a little bit, or absolute values often create those sharp points. Be another likely candidate. And absolute value really is just another way of doing piecewise anyway. So it's all kind of the same thing. Really good questions. Anybody else?
So like on that example at x equals 5,
Mm-hmm.
it's
like right- Oops, yep, there.
yes, the limit from the left, or the slope from the left is equal to the slope from the right.
Sure.
Would you agree with that? But then, so like at x equals 3, how would you prove that just with limits?
So that's a really wonderful question. So what you'd have to do is something you probably don't want to do. So when we talk about limits, we talk about the idea of closer and closer and closer and closer. Like I asked the question earlier, like how close could you get to 3? So there is a way of doing that, a way of quantifying that. It's known as the epsilon delta proof. It's pretty abstract and pretty challenging. It basically says for every delta, for every x, there is a y or epsilon. And you can prove that for every x you could select, there is an epsilon. And you can show that like the closer and closer can be actually quantified. I don't know if we really want to go there during class. If you wanted to talk about it another time, happy to do it. But that's kind of where, like that's where you're going. Like how close could you get? That's really a delta epsilon question.
So why was this one not differentiable? Because the slope from the left and the right.
Because it's not continuous.
So
If it's not continuous, it's automatically not differentiable.
Okay.
Yes,
But
sir.
then the other way, it's not. Like if it's continuous, it's not necessarily differentiable.
Correct. Contrapositive versus original. Yeah, that's good logic. Yes, Matt?
So differentiability is, if P is the same thing as continuity of the graph.
Yeah. So if f is differentiable, then f prime would be continuous.
Okay.
Is that what you were getting at?
Yeah.
Yes, that's true.
But
Caitlin.
wouldn't this function not be continuous because the definition of continuity is left-hand limit equals right-hand limit?
So when you said this function, are you referring to f?
Yeah.
Yeah, so f is continuous for sure. We're going to find that f prime is not here in just a second.
Okay.
But f is continuous because for any point you pick, think this through. So the line over here, we know that lines are always continuous. And whether this thing over here is a parabola or a sine or cosine or whatever it is, we know that those are always continuous. So from a piecewise perspective, isn't x equals 0 the only possible non-continuous point or discontinuous point? Yet we can see that the limit from the left and the limit from the right are both approaching 2, and the value of the function is 2. So f is definitely continuous, but it's not differentiable for the reasons that we listed. Good question. Okay, fair enough. Well, let's do our graph here real quick. Let's graph this the way that we did before. Let's start by asking ourselves, we got that graph of f up above. Is there any place on that graph where you can see that f prime is 0? In other words, there's a horizontal tangent line. Where does that appear to be? Well, no, okay. So I would say we have a horizontal tangent line right there, don't we? But not at -3.
Oh, never mind.
That makes sense? What's going on at -3? What's 0?
It's the same slope.
The x.
Yeah, 2/3.
F prime is 2.
Yeah. Hey guys, listen. This is where we want to clarify what it is we're talking about. We want to avoid using the word it because it can mean lots of stuff, or even the function or the graph. So at x equals -3, f is not 2/3. At x equals -3, f is 0, right? It's crossing the x-axis. At x equals, listen. At x equals -3, f prime is 2/3. Do you see the difference? This is where we run into problems by saying, well, at x equals 3, it is this and it is that. Let's be really precise about what we say. So at x equals -3, f is 0, but f prime is 2/3. Two different things describing the same graph, right? But they're two totally different things. Okay, so where do you see f prime being 0? Yeah, right about here, right? Isn't that where the tangent line would be horizontal-ish? Pretty close? Okay. So on my graph down here, when x is 3, I'm going to put a 0. Now here's where it gets interesting because, well, what we just talked about, didn't we just talk about a point of non-differentiability?
Yes.
So how is that going to work? You know, something's not going to exist there. Let's go ahead and graph just the nice the smooth curvy part on the right. Smoothie, there's a new word for you, in math at least. On this interval here, what would you say about f prime? Negative. And the other interval over here? So I'm going to do something like this. Negative would look maybe like that. Positive would be like that. Does that work okay? Now, we know for sure that x equals 0, f prime doesn't exist, right? We already discovered that. So I'm going to put an open circle right there, because of course an open circle means it's not there, right? It's not defined right there. Now on the left, we had a line, didn't we? And what did we say the slope of that line was? That means that no matter where we are on that part of the graph, f prime is 2/3. So this is how that would look. No matter where we are, f prime is 2/3. Something like that. What do we have at 0? We got to jump, don't we? Let's think about what that means on the graph. Doesn't that mean that f prime jumps from 2/3 to something that's negative instantly? So you can see that point of non-differentiability being illustrated on that graph of f prime. And so this kind of goes with what Matt asked about earlier. If f is differentiable, then f prime will be continuous. But you can see that f is not differentiable, therefore f prime would have to be not continuous somewhere, at least once. You can see that happening there with that jump discontinuity. Okay. Hey, that was a really great conversation for basically one reason. You all asked really great questions. Keep it up. Keep it up, okay? I'll see you tomorrow. We'll finish out 2.1. We'll get to 2.2. It's